When you think of an analog voltage or an analog signal, think of a continuously changing signal. Here we have a signal that changes with time. On this axis, we have time. And on this axis, we have voltage. I'll call voltage V. When you think of a digital signal, think of something that changes from 0 to 1, changes rather rapidly. Stays a 1, goes back to a 0, stays a 0. Later time, it changes back to a 1. So here we have 0, 1, 0, 1. We may have another digital bit that changes differently. It may go from 0 to 1, stay as a 1. Time later, it changes back to a 0. 0, 1, 0. Now there are circuits that can analyze this analog waveform. For example, at this point in time, it could analyze this waveform as a digital equivalent. For example, it's at the high point in the waveform. So we may say this is all ones. And at this point where it crosses the axis, we may represent that as all zeros. That's the smaller voltage. And something in between, there'll be an in-between digital code. So we can analyze this voltage waveform, which may be audio waveform, and we can design circuits called analog to digital converters. It will take this analog waveform and produce digital data that we can store, for example, on a disk drive. So we have zeros, ones, etc. There are other circuits that we can take the digital data from this disk drive. We can create a circuit called a digital to analog converter, or DAC, and we can generate the original signal again. When you see an analog schematic diagram or an analog circuit diagram, you'll usually see resistor components, capacitor components, and inductor components. You might see something we call an operational amplifier that will look like this. We'll have a positive input and a minus input. Now when you see a digital schematic, you'll see symbols like this. This is an inverter. What it does is it takes a 0 on the input, converts it to a 1 at the output. Or it takes a 1 on the input and it produces a 0 on the output. So whatever is on the input, it inverts it. It's called an inverter. Now we have other circuits that do other functions. For example, this is a digital circuit. It's called a NAND gate. And it analyzes these three inputs, and based on the condition of the inputs, it produces an output. Another circuit that's digital, that's commonly used, is a NOR gate. Again, it has inputs and an output here. And the output reflects the conditions on the input. So hopefully this gives you some idea of the difference between analog and digital.